Hello, good evening. Welcome to my channel, JB Teguihanon. Please subscribe to those who have not yet subscribed. And let's jump into our study tonight. Green Building of the Philippines. Objective. What is the objective of the Green Building of the Philippines? So it says here in section 3, objectives. Okay, the objective or the Green Building Code seek to improve the efficiency of the building performance through a framework of acceptable set of standards that will enhance the sound environmental and resource management that will counter the harm gases responsible for the adverse effects of the climate change throughout the building's life cycle, including efficient use of resources, site selection, planning, design, construction, use, occupancy, operation, maintenance without significant increase in cost. The Green Building Code is set is a set of regulations setting minimum standards for the compliance and not intended to rate buildings. Okay, that's a very clear objectives of the code, right? So let's jump into some technical matter. So we have the in section 8. I like to point this out. Section 8, the building use, occupancy coverage, and application. So this is used if your total gross area or TGFA, as indicated in table 1 below. Here is table 1. So if your residential dwelling condominium is 20,000 square meter, then you are under the you're required to comply green building. If you have hotel and resort, it's your total gross floor area is 10,000 or more. If you are educational school, 10,000 square meter. Institutional hospital, 10,000 square meter. Business office, 10,000 square meter. Mercantile mall, 15,000 square meter. Mixed occupancy, 10,000 square meter. Okay. And then, yeah, there are some exemption here. And yeah, let's check this out. And then we proceed for the green building requirements in chapter 2. Chapter 2. We go to a technical aspect of this. Performance standards in section 9, we have energy efficiency. This is actually number 1. Then water efficiency, material sustainability, solid waste management, sites sustainability, and then indoor air quality. So actually, the mechanical engineers are in here, and in here 9.6, 9.1, 9.6, and that is the focus of the mechanical engineer. Very, very important. The energy efficiency, section 10. And then what happened is we have a building envelope. Building envelope is being prepared, designed by an architect. Okay, but if the material does not comply with the or affect the efficiency of your machine, right? I think mechanical engineer has to say, has to comment, has to audit the materials envelope and see and lay down and tell the architect, hey, architect, your materials are affecting the efficiency, energy efficiency, and thereby we're not complying with the code anymore. We need to comply, right? Because this is a law. Okay, and then we have building envelope 10.1 and 10.1.1 air tightness and moisture protection. Okay, and then yeah, there must be some gaskets with their stripping, door bottom sweeps, and seals with surround the windows and door assemblies, things like that. Purely architectural. But here in 10.1.2, glass properties. Okay, here is the requirement for the window to wall ratio, WWR. And then this one, solar heat gain coefficient. And then you have the visible light, VT. These are the properties of glass, which have been mentioned here. Okay. Then applicability, this measure applies to all building occupancies in table 1, right? Remember table 1? Let's go back to table 1. Here is the table 1. Occupancies means this guy here, all of this, right? Whether it is hotel, educational school, business offices, mixed occupancy, they have to comply with these class properties. And here we have the table 2, which give the value for suppose you have window to wall ratio, right? Window to wall ratio. So he says here as a requirement, WWR must be balanced with SHGC to maintain flexibility in design. To further describe, the higher the design building WWR, the lower the required SHGC in glass windows. Vice and to be vice versa. This does not, however, remove the option for building owners to apply windows with low SHGC for building with low WWR. Okay, what he is saying is that in the table, you can see that as the window to wall ratio increases, right, from 10, SHGC decreases. right? What is SHGC? SHGC is the um, solar heat gain coefficient, is used to determine the amount of solar admitted through the glass divided by the solar radiation incident on the glass. Okay, so this has been um, the this is to be calculated by the architects. Okay, and then that value need to plug into the formula here. You gotta have this small f, which is SHGC correction factor for the external shading. If you have shading, okay, if you don't have, then there's no adjustment. Or adjustment is equal to SHGC right away. Okay, and this is the schematic of the window in relation to horizontal overhang or vertical fin. Okay, and you have the correction factor here for the edge D, the depth is your D over your height. You have the value there. Yeah, if you have zero point 0.1, then you will have a correction factor. That is F. You have to multiply your adjusted SHGC adjust is equal to F times SHGC, right? So it will become bigger or more bigger because the correction factor is more than 1. Okay, then you will have in 10.2, you will have a natural ventilation. This is also for the architectural consideration. How he achieved this. Then you have here a building color. This is also for architectural uh, consideration. And of course, you have here the property. If white, tan, dark brown, etc., you will have a value SRI. Okay, SRI is here. So the reflectance index, right? And then, yeah, let's proceed further. What is the exemption? There is no exemption. Take note of that word. Okay, and then you have the roof insulation. Roof insulation. In the roof insulation, you will have a value called, we have this, right? Mechanical engineer had studied this in the subject called heat transfer. So every materials has a property called R value. R value is the resistance of materials to the heat, because is a transit heat is a transit energy. It travels from higher temperature to a lower temperature. So a material has to resist it, and here are the given approved R value for common roof insulations. You have to meet these requirements here. You have to meet that. Suppose if you want to have a closed cell foam, okay, what will be the R value? R value must be from 5.5 to 6. You cannot use 5. You have to use minimum 5.5 to 6. You can use higher than 6, but not lower than 5. Okay? Okay, continue. But of course, the R has another property, and that property is the reverse of the R. The reverse of R is U value, U value, okay? That is actually U value is equal to 1 over R. Okay, that's the formula, basic formula. And why do you need U? Because the famous equation for your heat transfer, Q, small q, that is equal to U value of the materials times the area or cross-sectional area, or sorry, the area where your light is passing through times the delta T, change of temperature. Okay, so suppose you have a wall. I draw it in section like this. You have a wall here. You have your Q from height passing through the area of this wall of yours. Suppose your T out is high, temperature of outside, this is out, and this is temperature inside the, suppose, inside the house. Okay, in Philippines, suppose the maximum is 35 degrees Celsius, and in your room you will have 28 or maybe 27 degrees Celsius. So there is a difference between the two of these. So you have delta T, right? You have delta T, change of temperature. If you have delta T, then Q will transfer from outside higher region or higher temperature going to the, means your Q will travel from 35 degrees Celsius to 27 degrees Celsius temperature. Oh, okay, so it has to pass through this wall, but that wall has U value because it is a material, and every material has a U value. And then you have the area. You have to find out the area. Okay, if you draw this from this point of view or this view here, it can be look like this, suppose. Yeah. Then suppose you have your height and you have your L. Sorry, you have your L. Then you have your area, right? Your area shall be H times L. So you have this, you have this, you have this. You can calculate Q. Okay, that's all for today. It's getting longer. Please subscribe to my channel, JB Tigihanon. Thank you very much. Bye for now.